Hello and welcome to the MaML podcast. I'm your host, David J.H. Wu, and today I interview Jerry Liu, co-founder and creator of LlamaIndex, formerly known as GPT-Index, an interface that allows users to connect their personal data to large language models. Before we begin, I wanted to let our listeners in the medicine space know that this interview is a bit more technical than normal. LlamaIndex is an awesome tool that lets anyone connect their own data, whether it be PDFs or Excel files, to a large language model and do things like ask questions about it. We provide a high-level overview of the space and then talk about some of the nitty-gritty details of indexing one's data. There's a saying about how during a gold rush, you should invest in picks and shovels. LlamaIndex isn't a pick or a shovel, but I feel like it's going to be a very important tool in the future. If you're interested in learning more or finding a cool project, please join our MaML community Discord and follow us on Twitter at the MaML Podcast. Hello, everyone, and welcome to the MaML Podcast. My guest today is Jerry Liu. He is the co-founder and creator of LlamaIndex, formerly known as GPT-Index, an interface that allows users to connect their data to large language models. So my first question for you, Jerry, is a question that we ask all guests. I was wondering, can you tell us about your path and how you came to start LlamaIndex?
First, thanks, David, for the opportunity to be on here. I'm super excited to come and talk a little bit more about LlamaIndex, what it consists of, as well as the future vision. So I would say my journey has so far has basically been at the intersection of machine learning, engineering, and also startups. And I can talk a little bit about how I kind of arrived at this idea. And so maybe we could start there, actually. I started this project about 6 months ago. And at the time, I didn't really have an intention of starting a company around this specific space. It was more just I was very interested in kind of exploring some of the developments of large language models. At the time, a lot of things were taking off. People were using generative models like Stable Diffusion, DALL-E, and also starting to explore like text models like GPT a little bit more deeply. And I was very interested in this space, and I wanted to just figure out how I could, try to build an application using the GPT-3 API. There was a 4,000 token context window, and it seemed like GPT-3 was pretty good at reasoning. And so I figured, what if I just try to feed it some data? From at the time I was trying to build like a customer bot, so feed in some sales data from of notes from our existing customers at my previous job, and then build basically a basic question answering tool so that you could ask a question and then get back the results that you would want. And so at the time I started hacking around on the API and started building some of the basic abstractions to look into this, and I thought there's got to be like some kind of more principled ways of doing this, because I basically had like stumbled upon this idea that a lot of researchers were thinking about called in-context learning, which is you take this model itself and then you figure out how can I put stuff into this input window, which is 4,000 tokens or 4,000 words, so that the language model can not only just like, regurgitate information, but actually reason over this information that I feed it in order to, solve the task at hand. And so obviously the language model was not going to know anything about our company's like private customer data. But if I could figure out how to feed this customer data into the language model in the right way, then, it could be able to reason over this new information and then give me back the results that I would want. So that kind of inspired the initial iteration of GPT-Index at the time. Now it's called LlamaIndex. And it really started off as a design project, because this whole experience about dealing with private data got me thinking about this idea of, what if we augmented language models with some sort of like external memory? And then what would that external memory look like? And so again, it was a design project, had this idea of like a tree-based index. It actually didn't work super well at the time, but a lot of
tree-based index. Mm-hmm.
Yeah, exactly. The idea was to just like organize a bunch of information hierarchically into some sort of like tree structure, and then also have the language model be able to like look up information through this structure in order to retrieve the relevant aspects. So it was like kind of a design exercise in building some sort of like RAM or memory for this language model, which, by a computer-based analogy, you could think of it as like a CPU. And so the language model you can think of as like a reasoning engine with some like basic hash space in the input prompt. And then you want to figure out how do you actually feed the instructions and knowledge to this input prompt so that it could both like traverse, the like data landscape but also retrieve the right piece of information that you might
Mm-hmm.
want.
Mm-hmm.
So again, it was very much like kind of like that's the general idea that I started with, and it was an interesting project, and I think a lot of people were interested in understanding how it would work. As I started working on this a little bit more, it kind of became clear that I had stumbled upon a problem that a lot of users were thinking about, because a lot of developers that were starting to play around with language models for the first time were trying to think about ways that they could use it on top of their own data, right? And so that and like this data is just inherently stuff that the language model by default is not going to know about. And so I think as we were working on this project, we realized there really was an opportunity here to make this into a general toolkit that was accessible to the broader audience. And so that's what led us to make some of these decisions to basically turn this into something that was a design project and into a general toolkit that a lot of users could extract value from. And obviously have been very fortunate and lucky that there's been a huge growth in generative AI development in the past few months, and
Yeah,
so
so some great timing.
yeah, exactly. Very fortunate to be in the position that I am today, and we've built like an awesome community. A lot of people are building like data retrieval, search, and kind of general language model applications on top of LlamaIndex. Just a general note on my background before this. Before this, I spent some time in both like startups and research and ML. So I spent 2 years leading the machine learning monitoring team at Robust Intelligence. Before this, spent a few years in AI research as well at Uber. And then before that, spent some time in machine learning engineering on recommendation systems at Quora. So I have a little bit of experience in both like the research, ML, and also engineering sides of things. And typically, at smaller companies, with the exception of Uber.
Just curious, what was this is kind of a silly question, but what was machine learning engineering or work like before large language models? What did your work look like before that?
Yeah, so that's actually a good question. I could actually probably talk about this at length, because there's a lot of interesting thoughts as to how language models like transform the current machine learning stack, and it might have applications to how you think about like AI for healthcare too. With like traditional machine learning, and machine learning engineering, the focus really is on like the entire life cycle of data preparation, training, experimentation, and then evaluation. And so you kind of like separate training and inference, and there's like separate ops like pipelines for each of these. And I think, the idea is that before large language models, which are just way more general, you wanted to prepare a data set that you could train basically like a supervised machine learning model that could do like classification, it could do regression, it could do, object detection over some existing data set that you feed it. And so you run into a lot of challenges. And one, you need to gather the data with some ground truth. Two is you want to be able to train this model on top of this data. And then three is you want to be able to experiment with this data. And then four, or with this model. And the four is you want to be able to deploy this model to production. And so a lot of like my work, both in engineering, but also kind of like on the research side, was on like the focus was on like being able to train these models and being able to do it well. I think the interesting thing is with large language models, these models are already pre-trained on large amounts of data, and on its own, you don't technically need to change like a lot of stuff to get some value out of it. And so, a lot of the paradigms that are emerging nowadays, and obviously there's like fine tuning and distillation, and there's still people trying to like train these models for their own purposes. But a lot of paradigms that are emerging these days is really on how can you take a pre-trained model, and how can you take a pre-trained model and then just extract value from that. Like if you just take GPT-4's API, use it in inference only mode, how can you hook this up into some overall application pipeline and focus a little bit less on the training step? So I think that part's interesting, because it's kind of like it kind of necessitates like changes in the things that you want to emphasize and bring like features built on generative AI versus like traditional ML. Like necessitates like changes in how you think about the ops stack, like the things that would actually bring these features into production. But yeah, a lot of my background has been in the kind of like traditional ML space.
Can you say the 4 steps again? The traditional 4 steps, starting with
it's
data.
like, there's there's like data preparation, right?
Mm-hmm.
And then there's like model training, and then there's like just like experimentation, right? Just like the iteration process of this.
Mm-hmm.
And then 4 is like model deployment. And
Okay.
it's not just 4 steps. There's more steps I skipped. Like after you deploy the model, you want to make sure that you actually, you know, observe and monitor the model to make sure that
Mm-hmm.
it's still robust to like different types of drift, for instance, in your data, that, you know, the test distribution reflects your training distribution and all those types of things.
And so would you say with, these new like out of the box generative AI LLMs, or just I guess generative AI in general, um, how do you think that paradigm has shifted? It's
Yeah, that's a good question. So I think with generative AI models, if we buy that, you know, and this is something I'm not completely sure about, but if we buy that people are going to be training models a little bit less, and are more willing to just use these like pre-trained models out of the box,
mm-hmm.
then you're going to be spending less time, or basically zero time, on model training. You still
Oh
need to
wow.
prepare your data in some form for inference, but that's a little bit different than preparing like a training set,
So
where, you know,
steps 2 and 3 are just kind of um I I guess steps 2 and 3 are where I don't know, letting
so
like
that part's interesting, right? So steps to like model training, where you actually fit like a new model, will go away. In terms of
mm-hmm.
experimentation, actually, the way to think about this is like, you know, nowadays there's like a lot of emphasis on like prompt experimentation,
Yeah,
and so
yeah.
like here's like a very interesting way of thinking about it, right? Like, what is a machine learning model? A machine learning model is something that takes in some input, and then you know, as X, and then given the input and some parameters, gives you an output. Those parameters, you know, in traditional machine learning is like the weights of the model,
Yep,
basically.
yep.
Uh, Now with a pre-trained model, what exactly is the input and what is the output, right? You could think of the
Mm.
input as the specific task that you want to solve, but this task could be, you know, part of some overall prompts, and those prompts could actually be part of the parameters. Like, I guess there's kind of like a blur between like, you know, what you feed in as input and what's actually the parameters of the model. And so you
Mm-hmm.
still want to actually experiment with like different types of parameters with the pre-trained models. You're just like maybe not necessarily training the model itself, but you're experimenting with prompts, right? You're
Yep.
basically trying to see like what words you want to tweak, like, you know, how can you actually
Like
instruct the
how you
model
ask the
to give you
question,
the
right?
best result. Yeah, and so there's still a need for there's definitely a need for being able to experiment and track models, and you could even say it's like even more important or even more challenging than, for instance, like traditional machine learning, just given the
Oh.
nature of the complexity of the inputs and outputs. Like, you're not just outputting like a single number, you're not just outputting like a floating point
Oh, okay.
number, you're actually outputting something that's like an entire text, right? And you're also taking as
Uh-huh.
input like unstructured text too.
Yeah.
And so like, and actually we can talk about that too. Like, I think there's differences from the traditional machine learning stack. At least right now, if you're building applications, you typically don't need to like prepare data in the traditional way, and you also don't need to like train the model. You also don't really need to get like ground truth
Mm.
labels for your data. That
Wow.
said, you still do need to prepare your data in some way, right, to use with these models, and that's kind of where LlamaIndex comes in. And then
Mm-hmm.
you still need to have some emphasis on like, you know, good experimentation, tracking, and also like observability and those types of things. And so you know, like, especially as people are playing around with these language models and building applications, they're starting to realize the importance of actually properly like evaluating the performance of these models and tracking how well they do over time.
Yeah, and I guess that's so from my understanding, Llama Index is it's like connecting your external data to the large language model. It's almost like the bridge between step 1 and step 2, would you say? Or
Yeah, so LlamaIndex is connecting your external data to language models. It's not necessarily doing it in the sense of like traditional ML, where you need to like prepare your data set as like a training data set with like with like you know, input and then a ground truth label. It's just
mm-hmm.
like being able to like format and structure your data in a way that you can use with the language model during inference time. And so the
Mm.
model is already trained, but just like, how do you figure out how to feed this data
It's almost
into the
kind of like
model itself?
chewing it up, digesting it, and I guess
Yeah,
giving
yeah.
mm.
That's one way. That's one way of looking at it. Yeah. And so, like, just as a very basic example, for say, like, some of the listeners, like, imagine you just let's say you just have a PDF, right? Just any PDF of that's like 10 pages long of just text, right? Maybe there are some tables in there too. You take this PDF, throw it in some PDF parser, extract some text. Nowadays, there's like a bunch of PDF parsers out there, and then you just like structure this text somehow. Like you like chunk it up. You chunk up the text right into just these like text blocks, and then you store these pieces of text in some like data collection, right, through a database or in memory. And then now, maybe you add like an embedding for each text. Embedding is just like a vector of numbers, and you basically annotate each text in some way.
For the chunk of text, I did read the documentation of LlamaIndex. Is that the node or the different nodes, or am I getting it wrong? Sorry.
Yeah, exactly. So
so
each
you
chunk of text, yeah, within our framework, we call it like a node. And this is just something that's becoming pretty popular these days. And why do you want to have like chunks of text? It's because you want to have like just units of text that could fit into the input prompt window. And so, if you have a 10-page PDF document, that entire thing is not necessarily going to fit into like the input prompt window of GPT-4, because the input prompt window of GPT-4 is like 8,000 tokens. For Chat-GPT, it's 4,000 tokens. And so if you chunk it up, then for each chunk would be able to fit into that window pretty well.
And when you chunk it up, well, and I guess for our listeners, like 4,000 tokens, that's if you were to use just text, like that would be like a couple pages of words, right? Or
yeah, it'd be like a few pages. It's actually pretty long. I think the 4,000 tokens is around like 3,000 words, and so how many pages is 3,000 words?
Oh, yeah, that's
I
like
forgot
6 pages.
Exactly.
Yeah, that's around 6 pages.
Yeah,
7,
yeah. So it is pretty long. I think if you wanted to, you could actually get by just like for a lot of use cases on like small data, you could just fit everything into the input prompt window and get back a response.
It's like having it open its mouth and just throwing everything into
yeah, exactly. Like if you ever played around with Chat-GPT, you could just feed in like your entire English essay, right, and then just ask it like questions about it. The downsides, I think, of doing that are, one, some degree of like latency and cost. Like if you just naively always maximize the prompt window, OpenAI charges per token, and so then every call is going to use up like the entire set of tokens. The other part is like a lot of times you are just going to have more data than what data can fit into the prompt window, and so if you're dealing with like a knowledge corpus that's like gigabytes or terabytes big, how do you actually figure out how to like structure this in a way that you can actually use with the language model?
Do you store the nodes like in a vector, like in a series of numbers, or I guess how do you store the nodes?
Yeah, it's a good question. So this is also just like kind of hopefully a high level introduction to some like basic stacks that are emerging. So one stack that's emerging that's pretty popular is, the key question is, how do you create and store all this private data that can be gigabytes big with and use it with the language model? And so if you have like say gigabytes of private data, you can take each document, convert it into text chunks, and then add an embedding or a vector of numbers for each chunk, and then store it in this thing called like a vector database, right? And a vector database is just one of those, like a database that specifically is able to store like a block of unstructured text plus like an embedding associated with it. And let's say you have like a question, right? And you basically want to look up the relevant pieces of text within this database that are relevant to the question. That's basically what vector databases are specialized for. It would take in this input question, generate an embedding for that question, and you can match like the embedding between the query and the set of documents that you store to look up the most relevant documents, or most relevant chunks, basically relevant to the query. And once you actually query this vector database with the question, you'll be able to get back like the set of retrieved documents that are
kind of
close
to it. Query. Oh, okay.
So for instance, if you ask a question about like I was just trying to think of an example, right? Like if you ask a question about like hospitals, right? And let's say your knowledge corpus is like all of Wikipedia, it'll be able to return you like maybe the set of documents that correspond to hospitals. Right?
This is kind of a silly example, but is it kind of like SKU numbers on barcodes, like you kind of get the barcode and then it's like, okay, like if you buy soap, like I'm sure, like I think like the soap barcodes are kind of close to each other, maybe, or I don't know if I'm remembering that correctly, but
Oh, is that actually how that so I'm actually not super familiar with barcodes, but yeah, if soap, like for soap, like the barcodes are all close to each other, then yeah, that's kind of one way of looking at
maybe
it.
I
Yeah.
actually actually maybe a better one would be like in the library when you have books. I think like the Library of Congress, like
Mm.
the way that they have the book. I don't know if it's called barcodes or codes, but like they'll group it by category. Like all of the history books are under like the history section, and all of the
Yep.
cooking books are under cooking. And so maybe it's a little similar to that.
Yeah, so I guess for listeners, like if a vector, an embedding is just like a vector of numbers, right? And so
Mhm.
like the closer two vectors and numbers are to each other, and you can measure like distance via, like Euclidean distance, like dot product, like cosine similarity, and a variety of other metrics. Then that means that they're kind of like more semantically meaningful. And so, for instance, like apples and oranges probably relatively similar because they're both in like a fruit category. Like doc medical stuff, like doctor, hospital, etc. Probably the embeddings are similar to each other too because
Oh
they're
man,
also in a
I
different
love
category.
when math comes back like this. Like this
Yes.
is great. This is
Yeah.
beautiful.
Yeah, so like there's obviously embeddings have been around for a while. I think that the difference here is I think there's been a lot of more sophisticated ways of generating embeddings. Like it used to be that you could generate an embedding for each word or every like small set of words. But now with something like OpenAI's endpoint or Cohere's endpoint or a lot of these like Hugging Face models, you could throw in like an entire paragraph and it'll give you an embedding, right? And so the idea is that if you have like a question, just like a natural language question, um, and then you have a set of like relevant documents within your collection that are semantically similar to this question, you can like get an embedding for the question, get an embedding for all the documents, and then return the set of documents that are relevant to the question. So that's just step one, right? That's like being
Yeah,
able to retrieve the relevant documents to the question. And at this
that's pretty
point, like
cool.
you haven't even used the language model yet. So this is just like the basic stack that I'm describing. Once
Yeah.
you retrieve the set of relevant documents, now you have the language model. You can basically tell the language model something like this, like, hey, here's like a bunch of context, and then you
Yep.
throw in just the context itself as just like a bunch of raw text, right?
Oh,
Like
you
you,
throw the
you
raw
retrieved a bunch
text.
of documents.
Oh, okay, yeah.
Yeah. Yeah, so
Hmm.
like you retrieved a bunch of documents from this knowledge corpus. Each document is just like text, right? It's like
Yep.
some paragraph or a random piece of text. And then for the when you actually send this to a language model, you could format the input prompt as following: like here's some context, and you throw in this context as raw text. Now,
Yep.
given this context, here's a question, and then here's the question that you want to solve. Now, please answer the question. You send this entire thing to the language model. Hopefully it fits within the 4,000 token limit. If it doesn't, there's like strategies for dealing with this too, but
Hmm.
assuming it does, then it'll give you back the answer given this context that you put in.
That's beautiful. Wait, so then, wow. So that's step one would just be kind of like you have your data ready, or I guess
Mm-hmm.
your PDF of hospital data, and then with LlamaIndex you would kind of chew it up, I guess,
Yeah,
into
chew it
your
up into chunks, and
into
then you could like
chunks.
store it, and then like then basically when you ask a question, you'll retrieve these chunks and then feed it to the language model, and then you'll get back a answer. And so actually going back to I think one of the first points about like data processing, it's kind of interesting. On one hand, you could kind of think about data processing as being like, especially at least to get something up and running, you can think about the data processing part as being like trivially easy because you don't really need to format the PDF as well at all. Like you don't
Yeah.
need to like have some sophisticated parser that takes in this raw PDF text and really like strips out all the tags and new lines and write a bunch of code to format it. One of the beautiful things about language models is the fact that they can just take in like pretty unclean data,
Yeah.
and with a bunch of stuff in it, like raw HTML, web pages, like API documentation, stuff with a bunch of like bullet points, formatting, and then it can still understand semantically the content that you feed it. And so on one level, you could say that data processing has gotten a lot easier with language models. And LlamaIndex is capitalizing on that because, the default way of like structuring this data is not by some complicated parsing. It's just by like, maybe splitting up the text and then just like storing this like unstructured text somewhere. I do think, though, that as users are starting to build more and more of these LLM-based applications, and they're thinking about like potentially more sophisticated, like production level use cases for like language models on top of their data, then you're starting to revisit this question of like data structuring. Like, what exactly are the best ways that we can store data that we want to use with language models? Is it really we just like split up a bunch of text and save that? Do we need to add like annotations? Do we need to define like relationships between this data in some other way? And so I think those are all areas that we are thinking about too, because we want to make this not only just like super easy to get off the ground and running, but we also want to make this useful in like a production setting.
Yeah, and one of my big questions, I saw in your documentation, you said there's the new version of LlamaIndex recently came out. Congratulations. And I saw there's 3 key abstractions. You said we've redesigned LlamaIndex around 3 key abstractions that more cleanly decouple state from compute. The first being the index, which I guess that it says here, it manages the state, abstracting away underlying storage and exposing a view over processed data and associated metadata. So is that kind of like the chewed up part we're talking about?
Yeah, exactly. And so if you think about like the way we think about LlamaIndex, it's you start with like the data, which is like state, and part of LlamaIndex is being able to store state. And so there's the raw data itself, and then there's these like indexes on top of the data.
So that's the first abstraction, right?
Exactly. Yeah. So the indexes are the ways you can like chew up the data and process it in a way that you can use it with a language model.
And then the second is the retriever, which here says here fetches the most relevant nodes from an index given a query. And the final one is a query engine that synthesizes a response given the query and retrieved nodes. My big question, I feel like maybe this is a secret sauce here. Correct me if I'm wrong, but how does the retriever know which nodes to fetch given your question?
Yeah, so just at a very basic level, we have this concept of like a retriever, which is just like an abstract class in Python, and the interface it implements is you feed in some query or like a natural language query, and the goal of the retriever is to give you back the relevant nodes from your knowledge corpus. And again, the relevant nodes are just like the relevant documents from your knowledge corpus. And so, we just talked about this, but just a very basic example of what a retriever could consist of is really just using that like embedding based lookup approach that we described. So for instance, like getting an embedding of the query, using it to look up the relevant documents from like a vector database and fetching the most relevant documents. I think that's one example.
Oh, using like the Euclidean, like the minimal distance between the vector
like
numbers.
cosine similarity, Euclidean distance between the embedding of the query with the embedding of the document.
Okay, that makes sense.
To retrieve the most relevant documents. And then, there's like other types of retrievers that you could do too. Because this interface is so general, there's like a bunch of other retrievers that we support. And happy to talk about that as well. You can also do like retrievers on top of other retrievers. You could like arbitrarily define your own custom retrievers, but that's the main goal. I think in the framework of like this whole paradigm of like how do you best like manage the interaction of like a language model with your data, the retriever is a critical piece of this because really what's happening when you have this interaction is you have like a retriever model that's retrieving relevant documents from your data and then working with the language model to give you back the results.
And I feel like we, we should start talking about the medicine part too, because this has been fascinating to talk about, because I feel like everyone has seen firsthand how powerful, or I'd say most people have seen how powerful these large language models can be. And I'm sure a lot of people have wondered, oh, if I could connect this to my health data, I could, you could ask questions like, oh, like, given my recent like MRI report, like what does this mean? Or, given my like blood pressure readings from like the past 7 weeks, can you give me a description of blah, 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 blah. Do you think
Mhm.
that this could be applied one day to a person's health data?
Yeah, and I would be I'm almost certain like people and health tech companies are already doing this with language models, and barring some general concerns which about like HIPAA compliance, like privacy, like all these different things. But fundamentally uh like there's just like a ton of data in healthcare, right? And a lot of that is stored in text. And so for
Hmm.
instance, like patient history, like I guess just like your entire like medicine textbook, like just being able to kind of like understand like just ingest this entire corpus of medical knowledge to be able to like diagnose like a disease, and like analyze symptoms, those types of things. Like I think those are all pretty natural use cases that could be kind of like augmented with some of the power of these language models. And so if you think about just some of the core use cases that these language models solve, it's uh, at a very basic level, they can help you like answer questions given some data.
Yes.
Two is they can summarize stuff pretty well. Like if
Yeah.
you give it like this giant amount of text,
Mm.
like if you feed it like an entire like corpus of data, they could like summarize it into a paragraph. And just even on that level, there are probably just like a ton of applications to
Oh,
unlock
so
to
many.
basically, yeah,
I
just
know
like
our medical listeners, people in the medical field, like a lot of your job is like reading, at least at med students, you have to read their past notes, and then you kind of have to like synthesize your own note with all the previous history notes.
mhm.
Like as you said, yeah, it's just summarization task.
Yeah, and so I would describe those as kind of like relatively um like more on like the simple side, like one shot type tasks where you like basically use the language model over kind of like a more constrained data setting
Hmm.
to like do summarization, to answer questions. And I can imagine that would provide a lot of efficiency gains too. And I don't necessarily see this as like replacing doctors or like research assistants or anything like that, but I could see this like helping to provide a lot of like efficiency gains, maybe giving people themselves like a bit more visibility into their own like history and also like symptoms, and just being able to make a lot of this process like more efficient. And then I think there's another level, which is you have all this basic tasks over your data, like question answering, summarization. You can also extend beyond this into kind of like agent style interactions that can like
Mm.
help do research and do repeated tasks for you. This part is very interesting, just from a kind of like conceptual perspective, but I think there's also challenges in making it work well. For instance, like imagine like a research assistant that can actually do iterative research for you, right? Like let's say you have a question, it can not only like do a one-step approach of looking up stuff within your knowledge corpus, it can also like search Google, it could break this question down into like sub questions, like have a task list similar to what you see with like Auto GPT,
Oh
Bing
yeah.
AGI, those types of
Yeah.
things, and then actually just repeatedly go through until it's able to fulfill the task. Um, One really interesting project that we had from our contributors from our community is actually a project that does exactly that. It's a medical research assistant that goes on like a few kind of like popular sites,
Oh
and
no
then is
way.
able to like perform like a task for you given a query that you ask it. So that part's actually quite
What?
interesting. Yeah.
What's the name?
It's called Insight, and you could find
Oh
it
my
on our
God.
Discord. You could find it
I gotta take a look at this.
on GitHub as well. Yeah, 100%. So I think like just that part is very interesting, but of course I think there's just a lot of uncertainty about those types of applications, and a lot of that uncertainty is regarding like the trust level too, because like agent style
Mm.
interactions inherently require repeated reasoning from the language model. Then they're also just by nature of this going to be a little bit more prone to making mistakes. And so, then there's a question of how do you actually have like the human in the loop? How do you make sure it doesn't just like go off the rails? How do you like control the and refine the outputs a little bit?
Mm. Wow. And I feel like I should ask, I meant to ask this earlier. Um, there are probably other methods, there's LlamaIndex, but there's probably other methods of also connecting external data to LLMs. I was wondering, what are the pros and cons of the LlamaIndex method versus others? Um, yeah. You could
Yeah,
speak
I
to
think
that.
nowadays you can get a lot of the basic stack that we described through a variety of frameworks. For instance, like us, langchain, or you could just like spin it up yourself. And the basic stack is you just have a vector database like a Pinecone, Chroma, Milvus, Weaviate, and then you take in a bunch of documents, store it in the vector database, do like the top K embedding search from the database, and then take the documents and put it into the input prompt and send it to the language model. So that's like just a very basic stack of it's called like retrieval augmented generation. That's like popping up, and there's a variety of frameworks that help you do that. I think for us though, we are really trying to like generalize this into a framework that really solves a lot of different use cases around like retrieval and synthesis. And so I think we want to integrate with like outer application frameworks or agent like abstractions like a Chat-GPT plugin, or if you're like a langchain agent, if you're Chat-GPT, you can like use us as a plugin or a tool. But I think we want to just like be very focused on solving this problem of retrieval and synthesis and making that really good. And so just really thinking about what exactly are the challenges in managing, structuring your data, indexing your data, and then being able to query that data so that you're able to get back the best results that you can over your data.
That's cool. I feel like, of the whole workflow that you're talking about, steps like the old steps being 1, 2, 3, 4. It seems like you guys are covering really well of connecting your external data to LLMs. And it seems like you're working a lot with LangChain. You have a pretty good partnership with them, or?
I think we're like technically a separate projects, but we do integrate pretty well with LangChain. So if you use us, like it's pretty easy to integrate with the rest of your LangChain workflow, and we provide a lot of tutorials on how to do that.
Because to me, and for some of our listeners, I'm also just like learning what LangChain is, but to me it seems like it's a wrapper around LLMs that kind of lets you manipulate LLMs and use them more easily. Is that true, or would you say?
Yeah, so LangChain is a great framework. They have a lot of different building blocks around like a variety of different things. I think from like the LLM wrappers to embedding abstractions to some basic stuff around like data, like indexing, retrieval, and evaluation. So they touch on a little bit of everything, and we kind of integrate with LangChain where it makes sense. And so we're basically just like the kind of like we want to be one of the main modules around like data retrieval and synthesis. And so that's the part that we are, and then we make it really easy to integrate with like the rest of the workflow. If you're using like a LangChain LLM abstraction, if you're using like a LangChain, agent, to use us as like a tool, and then if you are using some of their evaluation modules too. And so this is all, for instance, like we kind of we like a lot of people are using LangChain to build different types of applications, and we just want to be like one of the core modules in this ecosystem. And so just like in general, there's like a lot of developer energy around this, and so we're super excited.
It seems so cool. It really seems like there's a gold rush, or I don't know, people love to use like speak in superlatives and say it's a Cambrian explosion or a gold rush. And there's that quote about during a gold rush you want to sell shovels. To me, like LlamaIndex seems like it's almost kind of like a tool that anyone can use, that allows you to connect your own personal data to the LLM. So it's not a shovel, but maybe more like a hinge, or like a I don't know, you know what I mean, like a spigot or something.
For sure. I think this actually gets into the next part of this 0.6.0 release that we put out last week. But I think along those lines of selling picks and shovels, we want to sell like or not sell, this is free, it's open source product, so everybody can use, but like we want to have like a high level API that makes it super easy for basically anybody, even if you're not super like technical, to just like get up and running on top of your data in about like 4 lines of code. And so that like you don't really need to customize at all. You just like throw it in something and over your data, and then you can get something up and running very easily.
I'm excited for that.
So
I would use that.
If you want to, you should check that part out. It's in the quick start as well.
Okay.
But we also want to make it really easy for you to customize. So if you do want to are like more advanced developer with like certain needs that you want to tweak, you want to like set different parameters and settings, you could totally do that too with LlamaIndex. And we kind of like make it so that it's similar to like an onion. You can like peel back layers and add your own stuff if you want. And so that's one of the beautiful things about some of our redesign.
Wow. What work in the AI and LLM space excites you the most?
Yeah, a lot of things these
Or I
days.
guess just generative AI. Sorry, just in
Yeah,
general AI. Yeah.
I think in general, there's like the generative AI piece. I think I'm very excited about, well, I'm very excited about like multimodality. I
Oh
think
yeah.
it's just a very interesting thing, way of understanding what the future stack is going to be like. If you could like translate text to images to audio, what are the implications for how you want to store different types of data? How do you just like, you know, basically unify all the different modalities of data in a way that you could like just easily convert between them. Nowadays, people are already building basic, it's pretty easy already to build bots where you could like convert audio or even images to text and then like reconvert it back into audio or text. And so
Whoa.
like that part I'm just very excited about. If you saw like the GPT-4 demo, it's like multimodal. I haven't
Oh, like
like
the
had
picture to the
access to that
website?
yet. But yeah, you could like take a picture and you could like, be able to caption that. So that part's interesting. I think the agent stuff is quite interesting too. And I think there's still a lot of opportunity in thinking about how much automation we can extract from the reasoning behavior of GPT by just having these agent abstractions as these like automated decision makers over anything, right? Whether it's data, whether it's like call an
Yeah.
API to do stuff. And I'm excited to see where that goes. And then I think in the overall AI space, yeah, I mean, I think if I just had to like throw something out there, like I think like physical robots. I mean, I used to work in self-driving. I think just like self-driving is not all like L5 quite yet, right? Because there's still a lot of complexity.
Oh yeah.
But
Yeah.
right now, everything we're talking about is in the digital space. I think translating this into the physical world is going to be really interesting.
Have you seen those deep mind robots recently? The ones that like play soccer and get up after you push them over?
Oh yeah, I think yeah. I mean, I think there's like Boston Dynamics, right, and like a few others
Yeah,
working on this.
those are. It's just scary to think that we're already close to an iRobot era where you just put an LLM into a robot and then it can move around and maybe you give it agents that allow it to like interact
Yeah,
with the
that'd be
world too.
interesting, and that'd definitely be very interesting, and
Ooh,
also
it's
probably a
kind of
little scary.
scary.
But yeah.
Do you ever feel doom and gloom or scared or kind of
Oh
the
yeah.
opposite of excited?
That's a good question. I think there's certainly cause for concern. I do think because like the project that we're focused on is kind of on a more limited use case. It's really about like unlocking insights from your data. So that
I
part,
feel like that's huge though. I guess
no,
it's
no, no,
limited,
it's
but
like it's not like that part itself is not gonna like burn down the world, right? So I think because
I
I've been
agree.
thinking
But
about
at the
that,
same time,
yeah,
it's almost like once anyone can
yeah.
connect their data to the LLM or the genie in the lamp, it's kind of like everyone is connected to it. You know what I mean? Like in a big picture, I feel like it's massive.
Um, yeah, I think so. I mean, it could certainly be a component of this overall system that ends up going haywire, right? And so I think there's definitely some like cause for concern there. I
That's funny.
I think in general I'm pretty excited about the future though.
Yeah.
Yeah.
Oh man, that's a funny thought that if everything went haywire, maybe LlamaIndex did play a small role.
Yeah.
That's fun. Oh, I also meant to ask, what is the story behind the name LlamaIndex?
Oh yeah. I'm glad you asked. So like we had this name called GPT index. At the time we figured we were gonna probably change the name at some point just because I mean it turns out it was a good move. Like OpenAI, now
Yeah,
has this
they're
like
coming
branding
after
guide where you can't
everyone.
use GPT as like a prefix. We
Yeah.
also were thinking of like coming up with other stuff in an ecosystem. And so like for instance, like Llama Index to like other stuff, like we have Llama Hub and we have like Llama Lab as well.
Mm.
So we want a good prefix. So we were thinking about animals. And keep in mind, this is like a week before like Meta / Facebook came out with their model. And
Oh
so
yeah,
we
yeah,
thought
yeah.
about like two different animals. There were hippos and there were llamas. And
That's
we ended up selling on llamas. And then, the week later, Meta comes out with their model, which is literally just called
yeah.
llama. And so that's either like unlucky timing or it's like fortunate in the
That's
sense that
good
it just gives
time.
us free publicity. But either way, like it is what it is.
As you know, the mammal podcast, our mascot is also the llama.
Oh, cool. Yeah. A lot of
Yeah.
people like llamas apparently. So
Uh, And I guess, well, the llama, you can spell LLM using llama, but
exactly.
yeah, it's kind of funny. I like because we started the podcast in 2020, and I remember thinking about the name, and it was just because like originally we wanted it to be like learning about machine learning in medicine, and then there's a lot of L's and M's, and llama was what we came up with. But yeah, it's kind of funny seeing like there's a lot of different like
That makes sense.
llama energy in the AI and LLM space.
Yeah, exactly. Clearly everybody's thinking about the same animal. So
Oh man. Um, this is one of our closing questions that we ask every guest.
mhm.
What do you think the future of AI in medicine will look like in 10 to 20 years?
Yeah, I do think I'm pretty bullish on this idea of like just automation and democratizing access to like healthcare, I guess. And so I think like I do think in an ideal world, like a lot of this technology of just like kind of, language models, being able to connect your data really easily, being able to ask questions, get insights from that data, will just like be able to get people like a base level of kind of like information access that they weren't able to access before. And just because, barring any kind of like regulatory or kind of like other concerns, like privacy concerns over your data, I think language models can actually do a lot of that really well. And even if you just took the technology today and just like stopped advancing GPT-4, I'm sure you could do like a ton of stuff over just like medical history, like helping
Yeah.
people like understand, like
I mean, isn't that what
diseases
Sam
and
Altman said? He's like, "Oh, the era of large language models is over. Like GPT-4 is we were, like they're not like bigger is not better at this point or something."
yeah, and so I think there's just like a huge opportunity here to just like, completely just have everybody like be way more aware of healthcare in a way that's like super
Mm.
easy to access. And then, again, I don't think like doctors are going away. I feel like there's a lot of value in some sort of like human connection, but I think like there's just uh like just like a kind of like reprioritization of focus so that like we can have like medical experts focus on some of the more advanced areas, but at the same time have everybody be able to have like a base level understanding of what's going on.
And last question is, what advice would you give to grad students, medical students, just say like early career professionals, people who are excited about AI? What advice would you give to them?
um I don't know if I'm the best person to ask for this question, but I think
Why
if
not?
you well, because I don't know, I honestly like won't be able to give any like medical advice. But I think like I for like the AI stuff, I would probably just like try to stay on top of these trends. Like just understand ChatGPT. Like try playing around with some of these applications. Like use LlamaIndex, use langchain. Like build some of these apps on top of this data. I do think this is going to be the future. It's going to be something that like permeates a lot of different aspects
Yeah.
of technology, and I do think it's like for pretty much everybody having some of that level of technical proficiency to understand what's going on will probably just like give you a step up and helping to really adapt AI to this the medical field.
Well, thank you so much, Jerry. It was such a pleasure to have you on the show today. I'm really excited about LlamaIndex. I'm gonna try the new. What were you saying? There's like just a couple lines of code. The
Mm-hmm.
what's the is it just 0.6.2 or what?
Yeah, the latest release. We've always had this high level API, and it's the same with the latest release too. You can get up and running in around 4 lines of code.
What's it called?
Um, well, the latest release version is like the 0.6 release.
The
And
API you said?
yeah, the high level API. Yeah.
Okay, got it. I will take a look at that right after.
Yeah.
And thank you so much.
Well, awesome. Thank you, David, for having me.